All right, ladies and gentlemen, it's been a while, but here we are doing another screencast about conduction and convection, thermal conduction and convection, just kind of explaining what it is. I think it's an idea that you will pick up pretty quickly because we've talked about a lot of the ideas already, but here we go. You need to answer all of these questions in Cornell notes, okay? The first one is, what is thermal radiation? Which we already know. Why does the spoon heat up and cool down? Define thermal conduction. Why does hot air rise? Explain how thermal convection relates to density. And then make a model of why the wind blows towards the ocean at night. Okay, so here we go. The first thing is radiation. We've already talked about thermal radiation in our last unit with the infrared radiation. So you remember infrared radiation comes from the sun or from heat, anything that has temperature. Infrared radiation comes from that. And so pretty much we've got our electromagnetic waves and they move molecules and that causes an increase in temperature. Okay, so that was thermal radiation. Thermal conduction. Now, as we remember from our unit on matter, temperature is the same thing as molecular movement. So the faster molecules are moving, the higher their temperature is. So I'm going to show you a video, and this will demonstrate thermal conduction. And the conduction's happening between uh, water and a spoon. Okay? So here we go, from the beginning. We've got a spoon in hot water, a metal spoon. Here is the spoon. Here is the water. What do you notice about what's happening right now? All right, we'll do it again. Spoon that is cold, water that is hot. Cold, spoon, hot, water. What do you notice about the molecular movement? How is it that this energy, how is the energy coming from the water into the spoon? What is happening? Okay, I'll give you another example. We've got a hot spoon in cold water. Hot spoon, cold water. So hot spoon, how is the energy being transferred and how does that relate to molecular movement? Okay, that is something that you need to answer. Okay, so that is what thermal conduction is, what we just showed you right then, and you need to come up with your own definition based on molecular movement, okay, and the fact that the objects are touching each other. So now things get a little bit more confusing when we start talking about liquids and gases. All right, with liquids and gases, they don't necessarily touch each other like two solids do to transfer thermal energy, right? So things happen a little bit differently. Here's a great example. Who here has been to the ocean and you notice that this nice breeze that comes, nice wind that comes from the ocean and blows onto the beach? Well, it's important to remember also is that in the middle of the day, what happens when you run out onto the sand? You burn your feet, right? So, but when you go into the ocean, it's much cooler, right? So over the sand, the air is very hot, right? And if the air is very hot, the molecules are moving a lot. When they move a lot, they spread apart. When they spread apart, they decrease in density, causing them to go up, right? They're less dense, so they go up. Okay? Over the ocean, what happens is the air cools, right? Because the water is cold, so the air will cool, it will slow down, it won't be moving as fast, the molecules won't be moving as fast. They'll come together, all right? And those are the same, those cool molecules will replace the warm molecules, right? So these warm molecules rise, these cool molecules replace them, and therefore you have a sea breeze. Now think about at night. Who here has been to the beach at night? Well, at night you might notice that the sand gets really cold, but the ocean pretty much stays the same temperature. So, I wonder how that would happen. All right? Uh, that's one of your questions. Here's another cool example. This is what happens inside of the Earth. So we've got liquid rocks, okay? And the center of the Earth is very hot. So at the very center of the Earth, very hot, the liquid rock becomes less dense. It comes up. The liquid rock becomes less dense, it goes up, right? Because things that aren't very dense, they float. Okay, so it's less dense, and then as it hits the top, it starts to cool down. You can see it starts to cool down. All right, and as it cools down, it becomes more dense, and then it falls back towards the center of the Earth. Okay, so this is supposed to demonstrate thermal conduction or thermal convection, and this happens in solids and liquids. No, this happens in gases and liquids. And then our example with the spoon, that is what happens in with solids. Okay, so the solid is being solids and gas and liquids. All right. So hopefully now you can answer all of the questions. Here they are again. I expect you to bring them to class. If you have any questions, ask your friends. Please don't copy from each other. Okay. All right. Thank you.